In this multi-part series of tutorials, you will learn how to make a parametric tire, which means that at a simple adjustment of a parameter, you can change the entire width, aspect ratio, rim size, and number of treads. You will also learn about Cartesian planes, tangency, and so much more. This will test your knowledge of all that you've learned through prior tutorials made by the Learn It channel. You will learn a ton during this series, so welcome to the Learn It channel, Lesson 12, Part 1, Design a Parametric Tire. Before we begin, some of our viewers have asked how we move our models around so easily. We are using the 3D Connection SpaceMouse Pro. A link to it and to the SpaceMouse Compact can be found in the description. Basically, it helps you control the model like you have it in your hand. Stay tuned for more details in a future video, but we highly recommend ordering one to help you design faster and smarter. Also, we would love your help in considering buying us a coffee or becoming a patron. Links in the description will navigate you to how you can help. So the very first thing that we're going to do with creating this tire is to talk about how we are going to actually model it. Now, in previous tutorials, I have spoken extensively about looking at a model and starting with its primitive shapes or its basic shapes. So many of us as new modelers, we would look at this tire and think, well, the basic shape is a circle or a cylinder. Now, while that is true, that is not how we design revolved models. So we're not going to start with a primitive shape like a circle or a cylinder, but rather we are going to do what's called a cross-section view, or we're going to create a sketch on its cross-section. How do we find the cross-section of something? Well, if we have a model already, it's very easy. Otherwise, we're going to have to use our creative ability to think of how to design the cross-section. So I have actually created this model based on some pictures of tires that I looked at extensively. And I also looked at the cross sections online. You can do the same. But if we already have a model, it's quite easy to look at a cross section or a section analysis. How do we do that? Well, let's go to Inspect and we'll look here at Section Analysis. So we can just pick a plane that we would like to do a cross section on. Let's pick our YZ plane. Let's hit OK. And now we can zoom in and there is our cross section. So if we create this profile and then revolve it around the Y-axis, then it will create the tire in one shot. It's very easy to design using revolve and designing a cross section. Now, if we ever want to turn our cross section off, well, we can just look over here at our browser and there under Analysis, we have a cross section. We can make it invisible and visible. We can create other cross sections as well. Let's create one on the XY plane. And there we have it. The next cross section, section 8, I've made several before this already, so that's why it's starting at 7 and 8. But we can go between the two of them. Very simple. We can also edit them if need be. We can flip the direction depending on what side of the model we'd like to view. We can change the angle, distance, all sorts of different things. And there we have it. So the next thing that we need to know are all our parameters. If we can start early with all of our parameters, inputting them into our parameter dialog box, then it will save us a lot of time. That's part of the planning process of working with a parametric model. So what parameters do we need to work with? There we have it. On every single tire out there, at least in North America, from what I understand, we have this type of labeling system. So what do they refer to? Well, the P refers to the type of vehicle that it would be installed on. For example, a passenger vehicle. The next is the section width or the width of the tire, 250. This actually is referring to millimeters. That's right. Even in the United States, we have millimeters on the side of our tires. Then we have a /, and the next number is our aspect ratio, 75%. So the height of half of the section of our tire is 75% of the width. So we will need that parameter or that equation in order to create our parameter for our tire. And then we have the R, which is referring to, in this instance, a radial tire. And then we have our last two digits there, 21. This refers to our rim diameter. So those are all of the parameters that we can input right off the bat with creating our parametric tire. So let's do that in our model. Let's create our parameters. Now, as part of the modeling process, you as the designer, you need to think of these things. These do not come easily to all designers. You have to spend time. Of course, watching a tutorial, it's very easy to see me quickly input them on the screen. But believe me, this has taken hours of research. I am just sharing my knowledge with you so that you can benefit quickly from it. But I want to explain this to you so that you don't get discouraged. How come he can do it so fast, you might ask? He's so much of a better modeler or designer than I am. Well, no, it's just I've spent the time researching so that I can input what I have learned into the system quickly. So at this point, you can use your imagination as to all of the parameters that we will use. Give it a second, write them down. Once you've done so, continue with this tutorial. Otherwise, I'm going to start inputting the parameters now. So let's input our first. We are going to call this our rim diameter. Now, I've explained this in the past that with parameters, we cannot put spaces in between the words, and we could actually use an underscore if we'd like. Some prefer that. I prefer to separate my words with a capital. So this actually is case specific. If we use a capital, it will recognize it as a capital and it will keep that as a parameter permanently. So also make sure to use correct spelling. I cannot stress this enough. In the future, we'll actually have a very interesting trick for you, a secret about Fusion 360. In the third series of this tutorial on parametric modeling this tire, there's a little secret, but you need to spell correctly. You need to have a correct naming convention so that when you use coding in the future and you call up this parameter, because you spelt it correctly, your coding will work out properly. It will work correctly. But if you misspell and if you're unsure of how you spelled and if you don't care about spelling, well, you're going to run into a lot of problems in the future. So spell properly right from the get-go. It's very important. Now our rim diameter is in imperial. It's in inches. So let's just call this 21. Now we can input a comment there if we want, but we don't need to. Let's create another parameter and we're going to call this our tire width. Remember, our tire width is in metric. It's in millimeters. So for our unit, let's click on that and select millimeters. Our expression, let's just start with a 250 millimeter width. Let's go OK. Next, we're going to create our aspect ratio. For our aspect ratio, this isn't actually a unit of measurement. Although it is a percentage, we need to specify this as no units. We just want it as a basic number. So for our aspect ratio, let's put in 75. Now we also need a tread height. And we'll call this 0.375 or 3/8 of an inch. That's the height of our tire treads. We will also need a parameter that specifies the gap between the treads. So let's call this tread gap. And we will call this 1/4 of an inch. Next, we need our tire height. So let's create this parameter, tire height. Now this, we actually have to input a formula for it. So we're going to type in tire width. And remember, we don't have to spell the entire expression. It's a waste of time a lot of times. So we can just write the first letter or first couple letters. And then as soon as the parameter comes up, see, we can switch between them. Let's pick the tire width, press enter. It inputs it. Don't press enter twice because then you will save that parameter. So tire width times, it's an asterisk for our multiplication. We don't use the times or the X on our keyboard. because that doesn't work for us. So we actually have to do an asterisk for multiplication. We're going to do an open bracket and say aspect ratio divided by 100, close bracket. And it actually will calculate the value for us. Let's press OK. Because this is a formula, if we change the tire width or the aspect ratio, our value will also change correspondingly. So let's just prove it to you. Our tire width, let's select 200 mils and take a look at our value here. There we go. It automatically updates it. Let's go to our aspect ratio of 60. Well, there we have our value change as well. Let's just put that back to 250 and 75. Next thing we need to know is our tire outer diameter. Now, this is funny because a lot of us probably want to know, well, what's the diameter of the tire? But actually, nobody gives that information. What is given to us is what we see on the side of our tires that tell us all the information we need to know. The rim diameter, the tire width, the aspect ratio. We can calculate the tire outer diameter from those things. How do we do it? Here's the equation. Rim diameter plus tire height times 2 minus the tread height times 2. And there we have it. So if we add the tread height times 2 to this, which is right here, well, it will equal approximately 36 inches for this particular tire. So because we're actually going to design the tire without the treads to start and add the treads later, we need to calculate the tire outer diameter as this specific equation. Next, we're going to input the tire wall thickness, and we'll leave this at 1/4 inch. Next, and lastly, we're going to type in our tread pattern number, or the number of instances of our tread pattern that will wrap around our tire. So for this, we won't choose a unit. We'll just call this 44. Now, this is because I've already designed a tire. I know how many I would like to create around it. But remember, creating a parameter means that we can easily change it in the future to whatever we want. So let's keep it at 44 for now. Let's press OK. Now here we have all of our parameters already set in motion for our tire. This is great. So let's just select our favorite parameters, the things that will change often. We'll do our rim diameter, our tire width, and our aspect ratio. Again, all the things we see on the side of our tire. The other things, well, we can just go down into our parameter list and find them when we would like to change them. Let's press OK. Now let's start our sketch. We'll create it in the YZ plane. Now I'd like to explain one fundamental thing about mathematics here. There's some terminology that you need to learn that will help you with sketching in the future. Now here we have what's called a Cartesian plane. We have our x-axis in red and our y-axis in green. You might be saying to yourself, Learn It channel, you don't know what you're talking about. I'm looking at the view cube right now and I see up and down is z, left and right is y. Yes, you are absolutely correct, but this is referring to our model orientation, not to our sketch orientation. Our sketch orientation will always show green going up and down, red going back and forth. So we have to ignore the view cube right now and focus on our sketch orientation. Our Cartesian plane has what's called quadrants. Quad meaning 4. We have 4 of them. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Everything in quadrant 1 will be a plus value. Our x dimensions will be positive. Our y dimensions will also be positive, or our y values, I should say. Next, in quadrant 2, our x values will be in the negative, whereas our y values will be in the positive. Quadrant 3, both x and y will be in the negative. And in quadrant 4, our x will be positive, our y will be in the negative. This is fundamental math that all CNC operators and those who create models should be aware of. Why are those called quadrants 1 through 4? So just picture that we create ourselves a line and let's create an angle in between. If we dimension that, we have an angle, in this instance, of 51 degrees. However, if we change that angle, well, obviously this is going to get larger, 147. If we keep building that angle around, we'll have 180 degrees going to our x direction here. If we keep going around to our y line, in between quadrants 3 and 4, it will be 270 degrees. And if we go all the way around, we've got a perfect circle, which equals 360 degrees. So you might be asking yourself, well, why have I just learned all about quadrants? What does this have to do with a parametric tire? Well, here's the reason. Quadrant 1 is very special. Quadrant 1 has, again, all of our values in y as positive and x as positive. So if we can design our entire part, if we can sketch it in quadrant 1, what that means is that we can mirror it to the other side. If need be, we can also mirror it to quadrants 3 and 4. This saves a ton of time in our 3D modeling process, in sketching, in all sorts of different things. But this is trying to teach you a fundamental skill that advanced 3D modelers and sketchers use in creating their models. So we're going to create our sketch of our tire, our cross section in quadrant 1. So what I'm going to do is create a very rough profile of the tire in quadrant 1. So let's do that. Let's create a line, and I'll call this a construction line to start. And I'll do one both in Y and in X. And construction line, we select our line and press X. We can also select and deselect in our line type right there. So let's dimension our first line here as our tire diameter. Now, we would probably select this by default, and we would say our tire outer diameter divided by 2. Now we could do that, and this is proper, this is okay. This is one way of doing it, and that shows us our complete outer diameter there. But I'm going to show you a different way. Let's delete that. Press D, select our center line, select our endpoint. Now before we press the left mouse button to lock it in, we're going to press the right mouse button and select diameter dimension. And look at this, it creates an invisible entity on the other side of our, in quadrants 3 and 4, which shows the diameter value of what we would like to create. So we can just type in our tire outer diameter now, and there we go. It's the exact same dimension. The only thing that's different is it shows the diameter value, and it also has the diameter symbol in our sketch, which shows us that we're working with a diameter value. Great. Now I'm going to design a very rough profile of the tire. Let's do that. I'm going to create it with 3 arcs here. So this is going to be the bead that locks in with our rim. This is going to be the cross-section profile of the top of our tire, excluding the treads. And this is going to be the sidewall. So let's start adding our dimensions to the sketch. Let's first of all create a dimension that spans from our center line to our cross wall. This is our tire width. We're going to pick that. Now, we're going to select the point of tangency right here. If we haven't seen the tutorial already, please look to the top right of your screen. There is a tutorial that explains how to select points of tangency. It explains it very simply and easily. I encourage you to look at that to understand a little bit more of what we're going to do. If we're already familiar with dimensioning points of tangency, then continue on. So here we're going to right click, pick circle arc tangent, select that. And this is going to be our tire width divided by 2. There we go. To see all of the features that are not fully constrained, we can simply move them. Now, I'd like to constrain this as well. To do that, I'm actually going to create another circle. That's going to be quite big. I'm going to turn this into a construction circle, construction line type. And I would like this arc to follow the profile or to be concentric to this arc. Now we could actually make this whatever we wanted, but I'm just going to say I'd like it to be concentric to that. Now, Remember, our parameter that we created here, our tire outer diameter, is not including the tread height. So this is going to include the tread height. I'm going to hit D for dimension, select those two entities, and just specify this as our tread height. There we go. So this is actually the outer profile of our tire. Now, how far would I like this profile to extend? Well, just from what we see on the screen, I'm going to move it to what I think looks about right. And now I'm going to try and lock this figure in, but using a parameter as well. So let's create a dimension from our center line to there. And it looks like it's 1/2 inch less than this dimension. So let's click that dimension and say minus 1/2 inch. There we go. So now that is locked in as well. Great. Let's make this a little bit more reasonable there of what it will actually look like in real life. Great. I would like to specify this bead radius right here. So I'm going to type D for dimension. And I'd like to say this is going to be 1 inch. There we go. That looks like a much better bead. Now our profile is actually done. Now it's not fully constrained because our profile doesn't have the wall thickness added to it yet. But this is basically the profile that I would like to keep. So let's now set an offset. I'm going to bring those in and call it minus wall thickness. Now let's create an enclosed rad right here. So 3-point arc. Let's pick those 2 points. I'm just going to do an exaggerated arc to show you that we would like to make these tangent with each other. To do that, we can just pick our tangent constraint, circle to line. Now this is only 1 point of tangency. It looks like the other is tangent, but it will mess up if we do not constrain it. So let's constrain our arc to that line as well. Remember, there's no need to put a concentric constraint here because this line is an offset of the other line. So if this is concentric, or if this is tangent, I should say, then this will be tangent as well. So what else do I need to constrain? Well, I actually forgot one parameter earlier, and that is our rim width. So our rim is usually set in a little bit from the outside of our tire width. And the reason for that is we'd rather our tire rub against a curb rather than our rim. So let's create another parameter. We're going to call this rim width. And this is going to be a formula. We're going to take our tire width times 0.95. So our rim width is always going to be just 95% of our tire width. So let's hit OK. Now let's create a dimension to that point right there. So D for dimension, we're going to zoom in, center line, right click to point of tangency. And you can see as I move my mouse left and right, it actually selects a different point of tangency on that arc. So we want to make sure to pick the outer side. Let's do that. And this we're going to call our rim width. Oh, I'm not doing a divide by 2. That's why. So sometimes these errors happen, right? So let's go back to rim width divided by 2. There we go. That was the only issue. These things happen. Sometimes we get into a train of thought. We're not thinking. So there we go. We've done a rim width divided by 2 because we're only basing it off of the center line there. So next we also have to do the rim diameter. So let's create that. Center line, arc tangent to that point. And this is going to be our rim diameter divided by 2. Perfect. Now, one last entity that I have to constrain is this point right here. So I'm actually going to create another equation, select that point, and I'm going to say I'd always like it to be 1 inch past this. So let's select that dimension, plus 1. There we go. So now this is fully constrained. You can see that our profile is not closed, otherwise it would show up in blue. So to close it, I am going to click that and turn it into a solid line. Now we have a closed profile. Perfect. Let's finish our sketch there. Let's save it at this point. We're going to call it Parametric Tire. Learn it. Okay, so it's good at this point. Once we have fully constrained our model, let's change our parameters and see how it works. See if anything breaks. Let's go to 19 inches. There we go. How about our tire width? We're going to change it to 200. Our aspect ratio is pretty high. Let's go to 50. There we go. We've got an issue. So it failed to resolve. Please try revising dimensions or constraints. So something is off right here. Let's go to our... Oh, we've got two sketches for some reason. There we go. Let's turn that off. Okay. So we've got two dimensions in red right here. So what's happening? Let's just delete those two. Now, for some reason, it's not locking in on that. So let's create another dimension from there to there. And let's just call this our tire outer diameter divided by 2. See if that works. No. Okay, so sometimes we've got items that break, and that's a good thing. That's great to see. So we need to see where it breaks and why it breaks, and then try and fix it. So let's do that here. For our tire width, let's bring it back up to 250. Aspect ratio 40. There we go. So it's a matter of sometimes our tire profiles don't always work well together. So let's a 40% aspect ratio is very small profile as well. Let's just go back up to something more reasonable, like 60 for our aspect ratio. Tire width, let's go to 300. There we go. Our rim diameter, perfect. Let's go back to a 250. Tire width, aspect ratio 50. So you can see that our profile changes quite nicely. Everything's working pretty well. Now, stating that, you can see that we just cannot do whatever we would like with these parameters. They have to be reasonable. Now, we could spend the time to go throughout it and see what all changes. If we change the rim diameter, what else changes? How can we prevent it from breaking, from an alarm coming up? And that just takes more time. But for this tutorial, we're going to stick with what we have on the screen because this model will be able to use most reasonable parameters that we can specify a tire as. So if you would like to perfect the parameters, that would be great. Please put them down below in the comment section. We'd love to see perfect parameters so that we can do whatever we would like with whatever rim size or width size or aspect ratio so that our tire doesn't break. Please, again, put them in the comments below so we can all benefit from them. Let's go okay. So now let's revolve our profile around our y-axis. There we go. Now for our operation, we're actually going to create a new component. And I'll explain that later when we actually create the text on the side of our tire, why that's needed. There we go. Now, let's drag and drop our sketch into our component to keep everything together. Turn off our sketch there. Now let's mirror it. Select our mirror plane. There we go. And we can keep it at adjust and press OK. Now we actually have two bodies right here. We want to merge them into one. So let's go combine, target body, tool body, create our operation as join, and there we have it. Our tire, which is looking amazing at this point. Now it's not finished. Let's add some fillets to the outside. Let's do that. 1, 2. We're not going to worry about the inside right now. Let's just call it a 1-inch fillet. Now this is looking amazing. If we go to our right profile and then go to section analysis, let's pick our YZ plane. And there we have it. We've got a beautiful tire profile. Now let's just bring this off to the side. And again, we can look at our parameters. Let's start changing this a little bit. Our rim diameter, great. Our width, tire width, our aspect ratio. Let's go 65. This is looking amazing. 75. Great. Our tire looks really, really good. You can see that throughout the process here, you check your parameters often. Check to see if your model breaks, check to see if there's any errors that come up. But as of right now, we've got ourselves a bald tire, or our tire without any treads. So we need to add some treads to it. Now that is coming up in the next tutorial. So let's review what we learned in this tutorial. 1. We researched, understood, and created the parameters needed to make a parametric tire. 2. Created a section analysis. 3. Learned what a Cartesian plane and quadrants are. And 4. Tested our model. In the next tutorial, we will create parameters and sketch the tread pattern for our tire. In the final tutorial, we will learn a secret within Fusion 360 that will change the way you sketch text. Also, once the tutorials for the series is complete, we will be having our first contest as presented by the Learn It channel. Stay tuned for more info. So if you've benefited at all from this tutorial, please consider liking, subscribing, hitting that notification bell. It would mean a ton to us to get this channel into operation, into the system more, so that we can provide more tutorials for you. If you have any suggestions, if you have any comments, please write them down below. We would love to hear from you to benefit from your knowledge and your wisdom. Hope to see you soon. Thanks for tuning in to the Learn It channel, and see you again soon. Bye.